So here is the circuit given, question number 151. They are saying resistance of wire between any two adjacent dots is capital R. So this wire between these two dots has resistance capital R. Between these two dots also capital R. Between these two dots capital R. So like that, between any two dots resistance is capital R, that is given. We have to find equivalent resistance between A and B. So between this terminal and this terminal. Now such questions has to be solved using symmetry. If you look carefully, if I draw a line passing through A and B, you can see this side and this side look same. So this axis has parallel axis symmetry. And whenever there is parallel axis symmetry, what I told, points this side and corresponding points this side must be at same potential. So this and this will be at same potential, this and this will be at same potential, this and this will be at same potential, this and this will be at same potential. Also, I told any resistor that cuts perpendicular to this axis can be removed. For example, in Wheatstone bridge, if you remember, when I want resistance between these two terminals, and if I draw this line, you see there is symmetry this side and this side. So I told this point and this point will be at same potential. So no current will flow here. So this resistor, which is perpendicular to this axis, can be removed. So here, which resistor is perpendicular to this axis? Of course, this resistor, so that can be removed. Okay, using the concept of symmetry. Now, once that is done, you can see these two resistors are in series because there is no junction to divide. So this R and this R will give you a single wire of resistance 2R, right? This is your point number 2, remember. Okay. Similarly, this R and this R are also in series. So this will give you equivalent resistance 2R. Remember, this is also having resistance R. This also has resistance R. That is what they told, right? Resistance between any two dots is R. They may not have drawn like this, but they told it has resistance, isn't it? Now this 2R and this R are in parallel. So equivalent resistance of these two will be what? Equivalent resistance 2R into R. 2R plus R. 2R square by 3R. So it will be 2R by 3. So this can be replaced. These two resistors can be replaced by 2R by 3. Similarly here, these two can be replaced by 2R by 3. Isn't it? Now look carefully. This, remember, between these two dots, this resistance is R, remember. This is also R. So now between A and 3, you can see these two are in series. So these two can be replaced by what resistance in series? 2R by 3 plus R. That will be 3. 2R plus 3R, 5R by 3. Isn't it? So you can replace this resistance by 5R by 3 between A and 3. Similarly, between this A and 3, you can replace these two resistors by 5R by 3. Remember, this is also R, this is also R, and again you can see these two are in series. So you can replace these two by single resistance. How much? 2R. And this R and this R are also in series. So you can replace these two by 2R resistance, isn't it? Now this is also R, remember, right? Now that 2R and this R are in parallel. So 2R and R in parallel, we already saw 2R by 3. So this equivalent resistance will be 2R by 3. So again I can replace this by 2R by 3. And these two are also in parallel. You can see same voltage will be there. And 2R and R in parallel, already we did calculation here. So that will be 2R by 3. Now you see between A and B, these two are in series. So that will be 5R by 3, these two, plus 2R by 3, that will be 7R by 3. So now this circuit can also be replaced by a single resistor with resistance 7R by 3. Same thing will happen here. So you see, so nicely by using symmetry, the circuit is getting simplified. And finally, between A and B, these two are having same voltage. So finally, between A and B, the equivalent resistance is 7R by 3, and 7R by 3 in parallel will be 7R by 3 by 2. R and R in parallel is R by 2. So 7R by 3, 7R by 3 in parallel will be what? 7R by 3 by 2. That will be 7R by 6, isn't it? So the next question, 121, it says two cities, which I am calling it as A and B, are separated by 150 kilometers. Now there are copper wires used to send power from one city to another city, and the fall of potential per kilometer. So as you move along the current, let's say current is flowing this way, and you know current flows from higher potential to lower potential. So let's say this much is 1 kilometer. Okay. So when you go by 1 kilometer per kilometer, they said potential falls by 8 volt, meaning from here to here the potential difference is 8 volt. Also, the resistance per kilometer is 0.5 ohm. So this part has resistance 0.5 ohm. So current here can be found by using Ohm's law. So your current will be, for this part, potential difference is 8 volt. Resistance of this part is 0.5. So this will be 80 by 5. 5 ones are 5, 6 are 20. So current flowing is 16 ampere. So now the power loss is what? I square into resistance of the copper wire used, which will be 16 into 16 into, what is the whole resistance? Now 1 kilometer has 0.5 ohm, so 150 kilometer will have what resistance? 150 kilometer into 0.5 ohm per kilometer, right? This is resistance of 1 kilometer per kilometer. So this is the total resistance of the copper wire. So this will be half, and that will give you, this will be half, right? 1 by 2. So this will give you 2 sevens are 14, 2 fives are 75 ohm. Okay. This if you multiply, you will get 19200 watt. So now if I write point here, 1, 2, 3, then this will become 10 power 3 watt. So that will be 19.2 kilowatt. Okay. So the next question, 127, it says 3 bulbs have power 40 watt, 60 watt and 100 watt. Now these are obviously rated power. Okay, rated power. So these are the rating of the bulbs. Now voltage rating is not given, so you have to assume the voltage rating is same for all of them. So rated voltage is same for all the bulbs. Usually we assume 220 volt, right, in India. Now these three bulbs which have filament, the wire inside, have same diameter. So the filament, the wire inside the bulb has same diameter. So if this is your wire, this diameter is same for all of them. Okay, they are asking which one will be longest wire. Now you know that power rating is given, voltage rating we will assume same. So now power rating is what? V rated square by resistance. This is the formula. Now you want longest wire. Remember resistance is related to what? Rho L by A. Now the wire's material we have to assume same. Otherwise this question we will not be able to solve. So we have to assume all the wires used in the three bulbs have same material. So same resistivity. Now area will be what? Pi r square, and r square will be diameter square by 4. Now they told diameter is also same, right? So if you want the bulb which has longer wire, in this case I should say longest wire, so the length should be maximum. And if these two are same, then R and L are proportional. So if length is maximum, R should be maximum. If R is maximum and we assume same rating power, then power rated should be minimum. So this bulb will have the longest wire. Okay, see 40 watt bulb. Let's see the next question, 129. It says there is an electric kettle whose rated voltage is 220 volt and rated power is 800 watt. So if you apply this much voltage, it will consume this much power. In the book, by mistake, I have given here as 20 volt. Okay, so change it. And there are three bulbs. Each bulb has rated voltage and power, 220 volt and 100 watt. Now these four things are connected in parallel as shown here. One kettle, three bulbs. Now the voltage applied is 200 volt, remember, not same as the rated voltage, right? Whatever voltage I want to apply, I'll apply. Why I have to apply same voltage as rated voltage, right? Now understand, since the voltage here is not same as rated voltage, they will not consume these powers. Okay, first thing you understand. Now here in this question, we have to just find current here. So what we will do, we will find resistance of each one of them from the rating, because resistance depends only on the material, length and area of cross section if it is a cylindrical wire. So resistance has nothing to do with applied voltage or power consumed, right? Resistance is fixed for a given wire. So what is resistance of the kettle here? R kettle. Well, you know power rated is equals to V square rated by R. So R will be voltage rating square by power rating. So that will be 800 divided by 220. Sorry, voltage rating is 220 into 220 square divided by 800. 0, 0, 0, 0. You can cancel. 2 1s are 2, 2 1s are 2, 2 4s are 8, 2 2s are 4, 2 1s are 2, 2 1s are 2. So 121 by 2 ohm. So that is the resistance of the kettle. What about resistance of each bulb? RB, let me write. Again, voltage square, that is 220 square divided by 100. So that will be 484 ohm. So now we will replace all of them by one equivalent resistance. So in parallel, 1 by R equivalent will be 1 by R of the kettle is 121 by 2 will go up by 1 by 484. How many are there like that? 4 are there. So I must multiply with, no, 3 are there. So I must multiply with 3. I hope this 3, how I got you understood. See, 1 by R of the bulb, 1 by R of the bulb, 1 by R of the bulb. That will be 3 times 1 by R of the bulb. So 3 times 1 by R of the bulb. Okay. So this we have to simplify now. So this will be 484. 121 4 za, I think is 484. So this is 4 za and 4 2 za 8 plus 3. And this will be 8, 9, 10, 11. 11 by 484. That will give you 11 1s are 11 4s are 11 4s. So our equivalent, if you cross multiply, will come 44 ohm. Right? Okay. So this whole thing can be replaced by 44 ohm equivalent resistance. So we can replace this whole thing by R equivalent, which is equals to 44 ohm. So the current through the cell will be equals to now voltage is given, resistance is given. So voltage divided by resistance. Ohm's law, right? Internal resistance is not mentioned, so no need to write capital R plus small r. So this will be 2 2s are 4, 2 2s are 4, 2 1s are 00, 2 1s are 2, 2 1s are 2, 2 50s are. So finally it is 50 by 11. So current is 50 by 11. If you simplify, 11 4s will be 44. 6 will be carry, 11 5s. So it is 4.5 amperes. That is the current. What if they ask total power consumed by the circuit? Net power consumed by the circuit if they ask. Then voltage you know, so right? Applied voltage square by R total or R equivalent. So this is how you have to find the total power consumed by the circuit. Okay? V square by R equivalent. Don't think you have to add the rated powers of the kettle and the bulbs, because they are not actually consuming same power as the rated power, because we are not applying the same voltage as the rated voltage, right? So this way you have to do it. Now let's see the next question, 157. They are given 3 circuits with resistors and battery, and we have to find power dissipated or power consumed by the circuits, and we have to see which one is greatest and which one is smallest. So now I told before that to find power consumed by circuit, you have to first find the equivalent resistance of the circuit. Now if you look carefully, this is your Wheatstone bridge, right? Let me call this point as A, this is B, this is C, and this is D. So look carefully now. Between A and C there is this resistance, and between C and B there is this resistance. Then between B and D there is this resistance, and between D and A there is this resistance, and this 1 ohm is between C and D, and battery is connected here. So clearly if you turn like this, this is P, Q, R, S, right? And you can see all are 1 ohm, so it is balanced bridge. This one represents the resistance. Okay, I didn't write ohm, please understand. So since this is balanced bridge, remember this will be removed, and 1 in series will give you 2 ohm. 1 in series will give you 2 ohm, and 2 ohm and 2 ohm in parallel will give you 1 ohm. That means equivalent resistance of the first circuit is 1 ohm. That you remember. Now come here. Now you may think this is Wheatstone bridge, but it is not. For Wheatstone bridge, battery should be here, remember. So this is a normal circuit. This one and this one is in series, so 2 ohm. This one are also in series, 2 ohm, and this 2, this 1 and this 2 are in parallel. So equivalent resistance in the second circuit will be 1 by 2 plus 1 plus 1 by 2. 1 by 1 is 1 only. So half plus half is 1. and this is 1 plus 1, which is 2. So resistance of this circuit will be ulta of 2 is 1 by 2. So resistance of second circuit is 1 by 2. What about this circuit? This one and this one are in series, 2. This one and this one are in series, 2. 2 and 2 in parallel will be 1. 1 and 1 in series will be 2. So, after finding the equivalent resistance of the tree circuit, how to find power? Power consumed by a circuit, I told you, is applied voltage square by equivalent resistance. Now check carefully. Voltage applied is same for all of them. So if voltage applied is same for all of them, the smallest resistance whichever circuit has will consume maximum power. Okay, if applied voltage is same. So who is the smallest resistance here? Half, right? So this will consume maximum power. After that, who has smaller resistance? First one. After that, this has largest resistance, so it will consume least power. So this is the relation between the power dissipated. Now let's see one extra question. So I have given you a circuit where the resistances in the upper branch are 4 ohm and 4 ohm in series, here 2 ohm and 2 ohm in series. Now some current is coming whose value they have not given, and that current will divide obviously, right? I1, I2. Now they have given you power consumed in 2 ohm resistor, either here or here. Okay, so they have given you power consumed by 2 ohm resistor. They want you to find power consumed by 4 ohm resistor. So try yourself once and then see the answer. Well, since they have given power consumed here, we can write power consumed by 2 ohm will be current in 2 ohm, which I have written I1 square, into resistance of 2 ohm is obviously 2 ohm. So this is the formula I square R. So power consumed by this 2 ohm will be current in this branch, which is I1 square into 2. What is the power consumed? They have given 10. So I1 square into 2. So I1 square is 5. So I1 is under root 5. Now from I1 I can find I2. How? If I convert this to a simpler circuit, then this 4 and 4 in series will give 8 ohm. This 2 and 2 in series will give 4 ohm. Current here is I1, right? I will divide into I1 here and I2 here. So I2. Same division of current should happen. So now you know these two are in parallel. So current into resistance must be same here. Current into resistance. Why? Because voltage across 8 ohm must be same as voltage across 4 ohm. That is what happens in parallel, right? Voltage should be same, and voltage is I into R. So I2 into 8 will be I1 is root 5 into 4. So what will be I2? 4 root 5 by 8 amperes. And this is 4 2s are 8, so this will be root 5 by 2 amperes. Once I know current here, I know current here also. So now power consumed by 4 ohm resistor will be current in 4 ohm resistor, which is I2 square into resistance of 4 ohm. And what is I2 square? If you square this, under root 5 square is 5, 2 square is 4 into 4. That will give you 5 watt. Okay. Now let's see question number 160. There are three resistors A, B, C. Their resistances are given 3R, 6R and R. And when potential difference is applied across them, some battery you can imagine, they want what is the ratio of the powers, okay, consumed by the resistors. So one way to do this is, let's say current I is coming. That current I will divide here I1, I2. That will again add and I will go, right? So now power consumed by C will be obviously I square into R. So now if I can write power consumed by A and B in terms of I and R, then ratio can be found. So how to find power consumed by A? First I need this current. Now current I1 can be found by using branch rule, isn't it? So I1 will be resistance of opposite branch divided by sum of resistance into the main current. Main current is I. So this will be 6R by 9R into I. 3 2s are 3 3s are 9 I. R will cancel. Now to find this current I2, I can again use branch rule. Opposite resistance divided by sum of resistance into main current, that is I by 3. Or you could have told I2 is I minus I1, Kirchhoff's current law. So what is power consumed by A now? Current here, I1 square, 4 I square by 9 into resistance of this 3R, that will be 4 by 3 I square R. 3 3 is 9, isn't it? What about power consumed by B? I square into resistance of this. What is I2 square? I2 square will be I square by 9 into resistance of this is 6R. So 3 2s are 3 3s are 9, then I square into R. So now if I find the ratio, PA is 4 by 3 I square R. PB 2 by 3 I square R, and PC I square R. I square R will cancel everywhere, multiply with 3, 4 is to 2 is to 3. Okay? Okay, let us see question number 161. So here they have given you 3 identical resistors in this connection between A and B. Now they have given you the information about the resistors as 10 ohm, 2 watt. Now this is the rating, meaning this is the resistance of each bulb, 10 ohm, 10 ohm, 10 ohm, that is the resistance, and this much power can be consumed by each one of them maximum. So more than this power cannot be consumed, then the wire will either melt or you can say it will fuse. So this is the maximum power that can be consumed by any one of them. Now this is given. So having said this, what we have to find is find the maximum voltage that you can apply between A and B without exceeding this power. Now for consuming this much power, how much voltage should be applied? That we can calculate for each resistor. So P equals to V square by R. This is for each resistor, okay? For each resistor. I am not saying for combination. For combination we will see later. For each resistor they have given resistance and maximum power that it can consume. So how much maximum voltage can you apply? That formula will be connected by this only, P equal to V square by R. So V will be what? Under root P into R. So V maximum will be under root P maximum into R. Obviously R doesn't depend on voltage or power consumed. So from here, what is the maximum voltage each bulb can or each resistor can take? The maximum voltage that it can take or we can apply for each resistor, that will be under root 2 into 10, which is under root 20. So under root 20 volt at maximum we can apply. Now how to find what maximum voltage we can apply here? So we have to find maximum voltage that can be applied between A and B. So let's see, we can redraw this circuit something like this. 10 and 10 in parallel will be 5 ohm and 10 ohm. Let's say here voltage is V1, here voltage is V2. then the applied voltage will be obviously V1 plus V2. Isn't it? Now some of you may think to find the maximum voltage applied, for this to be maximum, these two should be maximum. And for each resistor, what is the maximum voltage? Root 20. So you may think root 20 will give you maximum applied voltage to root 20. To root 20, because you are thinking this will be maximum when these two are maximum, which is correct thinking. It is not a wrong thinking. For this number to be maximum, these two numbers should have their maximum value. And for each resistor, the maximum voltage is given root 20. So you can apply maximum root 20 here, root 20 here, root 20 here, maximum. So root 20, you may think 2 root 20. But that is wrong, because these two resistance should carry same current. That is 100% true. Therefore, voltage here and here cannot be same, because this is 5 ohm, this is 10 ohm, isn't it? So, because current is same in these two resistors, there has to be a certain relation between V1 and V2. How to find that relation? Well, current in 5 ohm should be same as current in 10 ohm. What is current? Voltage by resistance. And here voltage or potential difference between this point and this point is V2 by resistance. So 5 2s are 10. So V2 is twice of V1. So you can't have both under root 20 under root 20. No, because 2 is here. So this equation you have to satisfy all the time. Okay. Now the voltage across A and B must be voltage across this resistance plus voltage across this resistance. Right. Now to find maximum voltage that can be applied, we can't make both maximum because this relation has to be satisfied. So we have two options. Either V1 is maximum or V2 is maximum. Okay, so let's check what we will get in the two cases and which case is actually correct. So if I say V1 is max, then V1 will be how much? What is the maximum voltage for each resistor? Root 20. So V1 should be root 20. Now if V1 is root 20, what will be V2? 2 root 20. Now that is not possible because you cannot apply voltage V2 for the resistor greater than maximum voltage. Maximum voltage is root 20, so you cannot exceed root 20. So this possibility is not allowed. So now V2 should be max. That means V2 should be root 20. Then what will be V1 from here? V2 by 2, which means root 20 by 2. That is allowed, right? That is not a problem because this is not crossing the max voltage for any resistor. So therefore, if I go with this option, which is correct, what will be the maximum voltage that can be applied between A and B? This will be root 20 by 2 plus V2 is root 20. So that will be 2, 3 root 20. So that much maximum voltage can be applied. And this can be simplified as root 20 is 4 into 5. Right, and root 4 will be 2, that 2 and these 2 will cancel. So final answer is 3 root 5 volt. Okay. So that's how you have to solve this kind of questions. So now see this question number 164. So here is the circuit. There is a heater. In parallel to heater there is an unknown resistance whose value we have to find. And here the resistance is 10 ohm. And the heater has a rating of 1000 watt 100 volt, meaning if you apply 100 volt to this resistor, then it will consume this power. But here they have applied 100 volt and you know that 100 volt will divide here and here voltage. So this heater will not get 100 volt, it will get less right now. Therefore, in the question they told the power which the heater is operating, matlab the consumed power of the heater, will not be 1000, it is given 62.5 watt. So we have to find this R. Okay. So I hope you understood why this consumed power is not matching with rated power, because the applied voltage here is not 100. Here it is 100, but that 100 will divide here, obviously, right? Now, let us try to find resistance of the heater from its rating, because resistance doesn't depend on what voltage is applied or what power is consumed. So P equal to V square R, so R will be V square by P, isn't it? And this is rating. So what is the voltage rating? 100 volts. So 100 into 100 divided by 1000. So 1, 2, 3, 1, 2, 3, so 10 ohm. So basically I can replace the heater by a resistor of 10 ohm. So here we have 10 ohm resistance. Okay. Now the actual power consumed by the heater here is given to be 62.5 watt. So we can find current here. I, let me call it. So to find current here, what is the formula for power consumed? I square into R of the heater. And what is resistance of heater? 10. So current square will be 62.5 by 10. If I remove this point, 100 it will become. So current will be under root 25 by 10, which is 2.5 amperes. Am I right? So current here I found is 2.5 amperes. So after knowing the current here and resistance here, voltage here we can find to be equals to this I into this R. So 2.5 into 10, which is 25 volt. So here voltage is 25 volt. So here also 25 volt. Here is 100 volt. So this must be 75 volt. Right? 100 volt minus 25 volt. Let me put circle wherever I have found myself. Okay. Now here 75 volt, here 10 ohm. So current here, let me call this current as I net. That current will divide here, no? So what will be current here? Voltage here is 75 divided by resistance here 10. So 7.5 ampere. So 7.5 ampere is coming, 2.5 is going. So how much should go here? Here 7.5 ampere is coming, 2.5 is going. Here how much should go? 5 ampere we should go remaining. And once I know voltage here is same as voltage here also. So for resistance R, if you use Ohm's law, R will be V by I. Which V? Voltage across this R, current in this R. Voltage across this R is same as voltage across this R, which was 25. And current in this resistor is 5. So 25 by 5 will be 5 ohm. Right? Now let's do 165. It says there is a coil which has a rating of 100 watt, 220 volt. So if you apply 220 volt, it will consume 100 watt power. Now the coil is cut into two halves and the two pieces are joined in parallel. Now what will be the power consumed or energy per second? Well, here we will assume the voltage applied is same. So initially, if the resistance was R, okay, initial resistance, if R was the initial resistance, then when you cut into two parts, this is the wire whose length is L. When you cut into two parts, each part will have resistance now R by 2 because length will be L by 2. And now you are joining them in parallel and applying the same voltage which you applied before. That is our assumption. Now what will be the equivalent resistance of this? R by 2 in parallel will be R by 4. Isn't it? Now power consumed is applied voltage squared by resistance. Here we will assume applied voltage is same. So if resistance from here to here became 1/4, then power will increase 4 times, because power and R are inversely proportional. Here if the resistance was R, now the total resistance of the circuit became R by 4. So if this became 1 by 4, this will become 4 times. So power will increase 4 times, which will be P dash will be 4 times P. Assuming initial P was 100, this will be 400 watt. Okay. Let's see the next question, question number 168. So here 4 cells of identical EMF E and internal resistance small r are connected in series. That series combination is connected to an external resistance which is variable. Okay, so that capital R can be changed. So something like this, 1, 2, 3, 4, 4 cells are in series, and here is your external resistance which is variable. Now a graph between the terminal voltage across the combination is given with respect to current. Obviously when you change capital R, current will change. As current will change, terminal voltage here will change. This is the graph. Okay. Now they want the current in the circuit when the power dissipated is maximum in this circuit. Now if 4 cells are in series, we can replace it by 1 cell and 1 internal resistance, isn't it? What will be the equivalent EMF? That will be 4E, and equivalent internal resistance will be 4R, and this is your external resistance. Now the terminal voltage here, V, formula was E equivalent minus I into R equivalent. So now in the graph, this V is given here 5.6. Now look carefully at this point. What is current? 0, because this is on y axis and current is your x axis. So at this point, x coordinate, current should be 0, right? So if current is 0, the voltage is equal to E equivalent. So this is actually E equivalent. And I discussed this in class, if you remember, for single cell. Similarly, this 2 ampere represents what? Well, at this point your V is 0. So if V is 0, I into R equivalent should be E equivalent. Right? So what will be current that time? E equivalent by R equivalent when V is 0. So this number is nothing but E equivalent by R equivalent. So E equivalent we got. What will be R equivalent? Well, 2 ampere is equal to this, and E equivalent is 5.6. So if you cross multiply, R equivalent will be 5.6 divided by 2. That will be 2.8 ohm. Okay. So we have found the R equivalent of the internal resistance and the equivalent EMF of the 4 cells. Remember, they want the current when power dissipated is maximum. Now for maximum power, we know R external should be equal to R internal. R external is capital R, isn't it? And R internal is how much? R internal is R equivalent is 2.8. So R external should be also 2.8. So now current will be what at that time? E equivalent divided by external resistance plus R equivalent. But they want current when the power is maximum, and maximum power happens when R equivalent internal is equal to R equivalent external. But here there is only one capital R in the external circuit. So capital R must be equal to R equivalent of internal resistance. So capital R should be R equivalent, which will be E equivalent divided by 2 times R equivalent. E equivalent is 5.6 2 into R equivalent is 2.8. So this will be 1 ampere, right? So the next question 169, it says a cell develops same power across two resistances, external resistances R1 and R2. Find internal resistance. So if a cell which has EMF and internal resistance develops same power whether you connect R1 or R2, then how to find internal resistance? Well, power consumed is same, means P1 should be P2 and P1 will be what? I1 square into R1, I2 square into R2. I1 will be what? In the first circuit, EMF by total resistance. And what will be I2? EMF by total resistance. Sorry, external is different, internal is same only, right? Because the cell is same. If cell is same, internal resistance and EMF will be same. Only here we are changing external resistance. So internal resistance will be same, square into R2. So from here E square will cancel. So I will get R1 by R1 plus R whole square equals to R2 by R2 plus small r whole square. Right? So now this we have to simplify. So this will be R1 by A square plus B square plus 2AB is equals to R2 by A square plus B square plus 2AB. Now you cross multiply, you will get R1 R2 square plus R1 R square plus 2 R1 R2 R equals to, here you cross multiply, R2 R1 square plus R square R2 plus 2 R1 R2 into smaller. These two will cancel. And here if I bring this one this side, I will get R1 R2 square minus R2 R1 square equals to, take this one that side, R2 R square minus R1 R square. Here if I take R1 R2 common, I will get R2 minus R1, right? And here if I take R square common, R2 minus R1, R2 minus R1, R2 minus R1 cancel. So small r will be under root R1 R2. Okay. Question number 171, we need to find relation between the current at which a wire will fuse and the radius of the wire. And I have already done this part in one of my previous videos. I'll share the link in the description, so please watch it. So there I have shown the current at which a wire will fuse, okay, that is the limiting current. The square of that current is directly proportional to the cube of the radius of the wire. Let's see the next question, question number 172. So here we have two cells identical whose EMFs are not given. Okay, so we will assume EE. Internal resistances is given 1 ohm each. Now in the first case, the two cells are connected in series and an external resistance is connected. That time some current will flow, obviously, right? I1, let's say. Because of that current, there will be some heat produced. The heat produced, rate of heat produced is given P1, which is nothing but power. Power is power. Power means what? Energy consumed per second, right? Per second, and per second means rate. So rate of heat energy produced means energy released per second or energy consumed per second, which is power. Then the same cells are connected in parallel, and when you connect the same external resistance, that time the power consumed is P2. If P1 is equal to 2.25 times P2, then we have to find the external resistance. So P1, which is power consumed by the resistor in the first case, is 2.25 times power consumed by the same resistor in the second case. Current here will be different. Let's say I2. Now what is P1 here? Power consumed by resistor. I square into R. R is same here in both cases. And this will be I square into R. R will cancel. So I1 square will be this 2.25 I can write 225 by 100. Now if I take square root both sides, I get I1 15 10 I2. Square root of 225 is 15. Square root of 100 is 10. Now I1 is what? Current in the first case. EMF by resistance. What is the EMF of E and E in series? 2E. Resistance will be what? R 1 ohm 1 ohm in series. So R plus 2 ohm. And this is 15 by 10. What is current in the second circuit? Remember, equivalent EMF of E and E in parallel is E itself. And total resistance will be R, and 1 ohm and 1 ohm in parallel will be 1 by 2. So R plus 1 by 2. Okay. E gets cancelled. So this will be 2 by R plus 2. This will be 5 3s are 15, 5 2s are 10. Here LCM 2 if you take will be 2R plus 1, and that 2 will go up, and that 2 and these 2 can be cancelled. Now cross multiply. 4R plus 2, right? 2 into 2R, 2 into 1 will be equal to 3 into R plus 3 into 2, 6. And if you take this 2 that side and this 3R this side, you will get R equals to 4 ohms. Right?